Hello my dear students, this is Akash SD. Welcome to the ASD physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Mechanical Properties of Solids based upon the law of flotation. Okay, so first let's go through the question. The question is, a hollow spherical shell of outer radius capital R floats just submerged under the water surface. Water, keyword water surface. The inner radius of the shell is small r if the specific gravity of the shell material is 27 by 8 with respect to water. The value of small r is how much? And here these options are there. Okay students, so first let's decode the situation. So here you can see here one shell is this. If I talk about here, let's take here inner radius how much here? Small r, and outer radius how much here? Capital R. This is just submerged inside the water. And density of the water how much here? This is the density of the water, rho w. So remember that here, according to the law of flotation, any object will float when the weight of the object is equal to the buoyant force or upthrust. In this situation, apparent weight of the body will become 0. Okay. So what will happen that here? Remember that here, this one, downward there is the weight of the body, we can write here m into g, and upward there will be the buoyant force, I can write here b. Okay, see here, weight downward, buoyant force upward, and even if possible draw both the arrows equal. Okay, because both have to be equal now. So if I write here even the arrow also, for me even arrow also matters, for me arrow also matters. Okay, so arrow length should be equal, then only what will happen that here both will balance each other, more or less both these arrows should be same. Okay, so what will happen that here students here, for flotation, basic principle is this, for flotation what will be this, this buoyant force should be equal to the weight of the body mg, always applicable, and apparent weight of the body will become how much here? 0 always. Okay, so now after that remember that here, if I write here the values, the buoyant force is given by, the buoyant force depends upon the density of the liquid, and which liquid is this? Water. So density of the water basic into immersed volume into gravity, immersed volume, whatever volume inside. Mass is given by the density of the substance into volume. Okay, so density of the substance, let's take here rho s, and the volume how much is this? V, and here g is there, is it? Now what will happen that here, you can see very well, this g and this g will cancel out, is it? Now after that I can write here, see this rho w, and immersed volume how much here? You can see very well this. Now there is the no water inside, so this much volume is immersed here. Now this much, you can see the outer one, outer circumference. So what we can write here, this volume is given here 4 by 3 pi capital R cube, is it? Equal to density of the substance, and the volume of the substance. Substance is where? If you see this situation, substance is where? The substance is here. This is the, let me change here the color. Okay, the substance is here. This is the substance. Substance is present here. This is the substance. This is the substance is here. Okay, so this volume we have to use here. Okay, so you can see very well here students, the outer volume is 4 by 3 pi capital R cube. Inner volume is 4 by 3 pi small r cube. So if we want to know the volume of this substance, what we have to do here? We have to do here outer volume minus inner volume. So 4 by 3 pi capital R cube minus small r cube. Is it? I hope so. You are getting very well. Is it? So what will happen? This 4 by 3 pi and this 4 by 3 pi cancelled. Is it? Remember that here left side we are using the volume that is immersed, and this is the volume of the material, Okay, so now we'll write here, remember that, see here, this rho w into r cube is given by rho s into what we can write here, see, the capital R cube minus small r cube, is it? Now after that students, if I write here, see, this capital R cube by capital R cube, now the simplification is equal to rho s by rho w. Density of substance by density of water is called the relative density or specific gravity of the substance also. Okay, so what we can write here, see, this r cube by r cube minus small r cube is given here. Rho s by rho w means relative density. Relative density how much is given here students, or we can tell specific gravity, it is given here how much here? 27 by 8, is it? So that I will write here, see, 27 by 8. Now so after that, if I just make here the reverse somewhat, see, r cube minus small r cube by r cube is equal to 8 by 27. Just for the simplification, okay. So what this will become, r cube by r cube 1 minus small r cube by capital R cube is equal to how much? 8 by 27, is it? See, up to this we have done this. After that, what will happen that here, if I write here, see, small r cube by capital R cube will come how much here? You can take 1 minus 8 by 27, okay. 1 minus 8 by 27, is it? So here we can write here, see, small r by capital R cube is given by, just take the LCM, this is the 27. So 27 minus 8. So we can write here small r by capital R whole cube, is it? Is how much here? 19 by 27. Okay. Now if I write small r by capital R, we can write here 27 power 1 by 3 and 19 power 1 by 3. Is it? 27 power 1 by 3, you know very well how much it will come here. It will come here anyhow 3, because 3 cube means 27. So 3 cube power 1 by 3 means 3. 19 power 1 by 3. Remember that here, if I talk about here 2 cube means 8, 3 cube means 27. But this is between 8 and 27. So value will be somewhere between 2 and 3. So 19 power 1 by 3. Students, remember that here, this used to be 2.67. How much it is coming here, students? This 19 power 1 by 3 is used to be 2.67. Or we can tell 2 plus 2 by 3, this one I am writing, you see, 2.67, this used to be 2.67, 2 plus 2 by 3, because 0.67 means 2 plus 2 by 3, so how much coming here? 3 into 2, 6, plus 2, 8 by 3, how much is coming here? 8 by 3, remember that here, okay, 8 by 3, is it? That I have written, 19 power 1 by 3 value, how much here? 8 by 3, so when you will simplify this, it will come here, small r by capital, how much coming here? 8 by 9. Hence, small r value is given here 8 by 9 into capital R. Okay, capital R. Is it, students? So, can you see very well how we have solved this question? Is it, students? So, if you see here, all these things here, 8r by 9, here option is here. Which one option here? You can see the correct option is here, option A. So, students, I hope so. This video you have understood very well. There we have used the law of flotation. For that, the buoyant force should be balanced by the weight of the body, and apparent weight of the body will become 0. So, students, I hope so. This video you have understood very well. Keep studying, keep growing.